All right, guys. So today we're going to talk about 3.1. This is day 2. We're going to focus on substitution and elimination. Substitution and elimination. All right, so today the focus really is knowing when to use substitution and when to use elimination. If you want kind of a written explanation on the best time to use these methods, you can read that. I think it's just better to just show examples. And I think from those, you guys can see when to use substitution, when to use elimination. Basically though, to kind of give you the moral of the story to start, use substitution when you have one of the variables all by itself. Like there's no coefficient or the coefficient is just 1. And it's easy to solve for one of the variables. That's when you use substitution. Every other time, use elimination. Okay, so that's kind of like the moral of today's lesson. Okay, so let me just show you a bunch of examples. Remember, I am calling on people, so make sure you're paying close attention and you're following along. So you're ready if you get called on. Okay, so number 1, it says choose which method would be best to solve and then solve. All right, so find the answer. Before I actually call on people, let me show you a trick that you can use to make life way easier when it comes to these problems. The first thing I would do, besides, before I decide on substitution or elimination, is double check and see if I can, in a sense, reduce the equations. All right, I want to see if I can reduce any of these equations. So I'm looking at that top equation. And that top equation, I can actually reduce down those coefficients because every single one of those numbers, 8, 16, and 56, those are all divisible by 8. So I'm going to reduce down this top equation by dividing the entire equation by 8. And that makes life a lot easier when it comes to solving these, okay? So I divided everything by 8. Now, when I look at that, I have a variable all by himself right here. So I want to use substitution, okay? So help me from here by solving for x. Let me call on Alyssa. All right, Alyssa, help me from here. Solve for x. What do I do? Alyssa?
You would subtract or divide each side by -2.
Ooh, I don't want to divide. I want to isolate x. So I need to move the -2y over to the other side.
Oh, you would add -2y to each side.
Good. So add 2y, and then what do we get? X is equal to?
-7 plus 2y.
Good. I'm just going to write the 2y first, just because usually we put the variable stuff in front. All right, good. So we have x is equal to 2y minus 7. Okay, then Alyssa, I want to use substitution. So I'm going to substitute. Now that I solve for x, I'm going to plug that in for this x in the second equation. So what do I get when I substitute into the second equation?
3 times -2y minus 7 plus
Positive.
5y equals 23.
Good. And just make sure it is a positive 2y that you're substituting. Positive 2y. Sorry, I think my iPad stopped sharing. Give me 1 second. Okay, all right. Hopefully that, okay, we'll do it. All right. Now, keep going. Alyssa, let's solve for y.
Then you distribute the 3
Good.
to the other numbers in the parentheses.
Good. Okay. So what do we get? So what do we get? We got 6y. Keep going, Alyssa.
Minus 21. Sorry, the audio and visual is lagging for me, so.
Oh, okay. Sorry. It's okay. All right. I'll help you out here. Plus 5y is equal to 23. I get 11y is equal to 44. So Alyssa, I'll just give you that final answer. All right, so final answer for y. Y is equal to what, Alyssa?
4.
Good. We have already solved for y. All right, Gio, help him out.
You plug in you plug in y to the equation x is equal to 2y minus 7. So it's 2 times 4 minus 7, and that gives you your x.
Good. So x is equal to
1.
1. All right. So final answer, we want to put this into coordinates. So we have 1, comma, 4. Okay. All right. There it is. Okay, Jamie, make sure you're paying attention. All right, number 2. Let's go to number 2. This one. Let's go to Faith. Okay, so Faith, first thing, what can we do for number 2?
You can times the top equation by -4.
Oh, there's an easier thing to do. Like, for example, number 1, I saw that my first equation, I can divide everything by 8 to make the number smaller. So for number 2, can I do this?
Also, the second equation, you can divide it by 4.
Yeah, let's divide everything by 4. So negative 2x plus 3y is equal to 12. All right, and I'm just going to bring this guy over. Okay. And then Faith, which method do you think we should use? Substitution or elimination?
Elimination.
Good. All right, we don't have a variable by itself. So let's eliminate. And let's see what happens when I add these together. I get 0 for 2x minus 2x. I get 0 for negative 3y plus 3y. And I get 24 when I add 12 and 12. Does anybody know then what my answer is? Unmute yourself and just tell me.
Is it no solution? That's just a guess. I don't know. That could be
Perfect. Yeah, you got it. It is no solution. Good job, Heidi. So this will never be true that 0 is equal to 24. So because that's not true, this is going to be no solution. That's it. Good job. All right, let's go to number 3. Okay, number 3.
So you divide the bottom equation by 2.
Sorry, what?
First you subtract 6d over to the other side of the top equation.
Okay. Wait. Why? What's your plan?
To organize the two variables on the sides that line up with the bottom one. So then you can add it and then get rid of the c on the other side.
Oh, okay. So you're trying to align the variables. So I would maybe minus the 12d just to kind of, yeah. All right. And then what else can we do to make this easier?
You divide the bottom equation by 2.
Nice. Divide the bottom equation by 2. Good. All right. Dividing the bottom equation by 2. Okay, keep going, Zach.
And then you add the two sides, and then you get 0 is equal to 0, I think.
Eliminate, that gets 0. Negative 21 plus 21 gets you 0. So what does this mean? What do I do?
Is it undefined or?
Ooh, okay. So a lot of times students will say all real numbers. That's actually not true. Or they'll say undefined. That's not true either. Basically, if this is a true statement, that means you're going to have infinitely many solutions. All right, infinitely many solutions. If you guys write all real numbers, that's actually incorrect. You're not going to get the right answer. But what this means is that these two are the same line. When you graph it, like what we saw yesterday, you're going to get a graph on top of another graph. All right, so that's what this means. So that's why we have infinitely many solutions.
Do we have to write out infinitely many solutions every time, or is there a symbol for it?
There is no symbol for it. You do need to write it out.
Can you just explain why? Because it kind of seems like those are the same thing, but is there like a differentiation between?
Between 2 and 3?
Or no, between like infinitely many solutions and all real numbers.
Oh, yes, that's a great question. Yeah, when you say all real numbers, it means that if I were to shade the answer, all real numbers would be this entire coordinate plane, right? So that would be all real numbers. X can be anything, Y can be anything. So that entire coordinate plane would have all the answers. But that is not the situation. The situation is that all the points on this blue line, those are all the solutions to the system. And there's infinitely many points on this line. So that's why we don't like write out all the points. So there's infinitely many solutions, but it's not the entire coordinate plane.
Okay. Okay.
Yeah, great question, Heidi. Nice. All right. Other questions? Okay. All right. Good job, Zach. Let's go to Gino. Gino, help us out with number 4.
Oh, so I guess just use elimination for this
Good.
one. Just straight
Yeah.
off.
We can't divide anything to make it simpler. So yeah, let's use elimination. And I'm going to show you guys something. Okay, there's 2 ways you can do this. You can subtract and get rid of F. But a lot of times students make careless mistakes when they subtract. So instead of doing that, I'm going to advise you to multiply one of the equations by -1. And that actually saves a lot of people from careless mistakes. If you feel that you do not need to do that, and you can subtract without careless mistakes, feel free to subtract. If you are prone to careless mistakes, multiply everything by -1 on that second equation. And that saves people from careless mistakes. All right, so Gino, take over from here.
So df is gone
Good.
because it cancels each other out. And then 5g and then 26. So
20,
then, no wait, 25.
yes.
Yeah. And
All
so
right.
g is equal to 5.
Good, keep going. What do I do after that?
After that, you plug g into one of the equations.
Good, which one do you want to pick?
I guess the bottom one.
I think the top one's easier,
Okay.
just because no negatives. But up to you. Do you want to do the second one? We can do the second one.
We could do the top one then. I don't know. Okay.
All right, you do the top, or I'll do the top one, you do the bottom one. Let's see if we get the same answer. All right, so I'm going to plug it in. You do the bottom one. Let me pause share, actually. Let's see if we get the same answer. And just tell me your answer once you have it, Gino.
I got 6.
Okay, we did not get the same answer.
Maybe I did wrong.
All right, let me plug it into the bottom one and see what happened. So plug in 5 for G. And I get -3/2. What happened, Gina?
I probably just made a mistake along the way.
Yeah, look and see where you made the mistake. What
Miss Leong.
what happened? What happened, Gino? Where was the mistake? So other people can make sure.
The second step, I wasn't plugging it in.
Oh, okay. All right. So you know what though? That's okay, because you can catch that by plugging in your F. If you got F is 6, this would be 12 plus 15 is equal to 12. Right? So you would be able to catch that careless mistake. So always plug in, guys, and make sure that you double check your work, because it's easy to make mistakes. Okay. Thank you. Good job, Gina.
Miss Leong.
Yeah, question.
So could you still do it the addition and subtraction way? Because I feel like when I looked at it, I think you might get the same answer.
I
So
did.
instead of multiplying it by -1.
Yeah, you can subtract and you get the same answer. Is that what you're asking?
Okay. Don't add though. Yeah.
Yeah. Instead of
That's what I'm asking.
multiplying by -1, if you just straight subtract, you would get the exact same answer. The reason why I'm teaching it by multiplying -1 is I've seen so many students make careless mistakes when they subtract. They like forget to carry the minus. Yeah, so that's why. But if you are not prone to careless mistakes, then feel free to subtract. Okay, so now I need to put this in coordinate points, guys. So let's figure out which one do I put first. So it's alphabetical order. So what comes first, F or G? Nobody
F.
knows.
-3/2 and 5.
Good. All right. So yeah, sing the alphabet song. Which, by the way, did you guys know they changed the alphabet song?
Did what?
They changed the alphabet song.
Yeah, because a lot of people were going like LMNOP or like messing it up over there. So they put like a space.
Yeah. So we had to do LMNOP. Now they do LMN. OPQRSTU VWXYZ. So they changed it. There's no LMNOP anymore. Isn't that crazy? Man, 2020, just messing everything up. All right, good job, guys. Let's go ahead. Let me just do one more. I think you guys are feeling pretty solid. It's my impression. So let me just do one more with you before we move on to the word problem. But if you do want to see 6, 7, or 8, just holler and let me know and I can show you those. But we'll do number 5 as our last one together. Let's go, Ryan. Okay, Ryan, help us out with number 5. Which method would you choose, substitution or elimination?
Substitution,
Good, and why?
because both of them are already equal to y.
Yeah, it's already solved for. Okay, so let's use substitution and tell me what to write.
2x plus 1 equals 3x minus 4.
Nicely done. All right, so you substituted this for that y. All right, solve for x, Ryan.
Subtract 2x on both sides
Good,
and add 4 on both sides.
good. So x is equal to?
5.
Nice. What else do I have to do?
You sub in the x into your original equation,
Good. Which one do you want to pick?
the first one.
Sure. Good idea. I would have picked that one too. All right. And then y is equal to?
10 plus 1,
Which is?
11.
Nice. So final answer, coordinate.
5, comma 11.
Good job. Nicely done. Feeling better today, Ryan?
Yeah, I had to take the day off after I left this period. And then I just took medication and I was better after a few hours.
Good. I'm glad. Yeah. Do what you got to do to take care of yourself, guys. And yeah, just know that these lessons are recorded and that I record these so that if you guys do need to take like a break, like I get it. You can just watch the YouTube videos later. Yeah. All right. Good job, Ryan. Perfect. Okay. I think you guys are good. Hopefully, if not, let me know if you want to see 6, 7, or 8. All right. Unmute yourself and just yell out a number 6, 7, or 8. But if you're feeling good and you don't need to see those, don't say anything. All right. So, anybody? 6, 7, or 8. Okay. If not, then let's go to number 9, our word problem.
You mean 8?
Oh, sorry, what?
You mean number 8?
Oh. Thank you. I did not notice that. All right, my bad. Typo, this is number 9, JK. Good catch, Arwen. All right, Arwen, since you're looking at it, can you read that one out for us?
Okay, so fundraiser. To raise money for new uniforms, the band boosters sell T-shirts and hats. The cost and the sale price of each item is shown. The boosters spend a total of $2,000 on T-shirts and hats. They sell all the merchandise and make $3,375. Using the table below to write a system of equations to find how many T-shirts they sold.
Nice, thank you. Okay, so our goal is to write a system of equations and find out how many T-shirts they sold. Okay, so those are kind of the important things you should always be highlighting, especially with word problems, and pulling out the important information. Okay. So Arwen, since you chose or you read, I'll let you choose the variables. What variable do you want to pick for T-shirts?
T and H, I guess.
H, ooh, good choices. I like those. I like that you didn't pick X and Y because I think T and H is better because you can tell T is for T-shirt and H is for hat. So good choices. All right, let's write some equations. So Raheel, help me with the first equation. They spent $2,000, right, on T-shirts and hats. Each T-shirt costs $6 and each hat costs $4. So what's the equation we can write?
Maybe it's 2,000 equal, or maybe 2,000 equals 6T plus 4H.
Good. And I'm going to flip that around just because we're more used to having like the variables on the left. But perfect. Good job. Okay. Second equation. David, help me write the second equation. They made $3,375 and they sold each T-shirt for $10 and each hat for $7. So what would the equation look like, David?
10T plus 7H equal 1,375.
Good job. All right. Nice, guys. So we wrote a system of equations. Check. And now we need to solve for it. So let's do so. Let's see. Queenie, help me solve for these. What What can we do, Queenie?
I think that we could first simplify the top equation.
Yeah, good job. So what can we divide by?
Divide both sides, divide the whole thing by 2.
By 2, good. Yes, let's simplify that. Makes it a lot easier to handle. Bottom one, we can't, since nothing goes both into 10 and 7. All right. From here, I'm gonna need to use elimination. So let me help you out with this one because we haven't done one like this just yet. Because notice that there's nothing I can multiply 3 with, like no integer, that will get me 10. And there's no integer I can multiply 2 to get 7. So because of that, I actually have to multiply both top and bottom equations to get the coefficients to be opposites. All right, and the reason why we need them to be opposites is because that's what eliminates a variable. So I need to choose a variable first, either t or h. I'm going to choose h to eliminate because 2 and 7 have a multiple of 14, which is less than the common multiple of 3 and 10. So h is just a lot easier. So I'm going to multiply this top one by 7, and I'm going to multiply this bottom one by -2. And that way, the coefficient of h will be 14 on top and -14 on the bottom, which will eliminate. All right, so this gets me 21t plus 14h is equal to 7,000. And this gets me -20t minus 14h is equal to, let me do some mental math here, 0, carry the 1, 5, carry the 1, 7, and 6, and negative. All right, so -6750.
Wait, why'd you multiply it by -2?
As opposed to +2, or?
Yeah.
Because I want these two numbers, 14 and -14, to be opposites of each other. That way, when I add, they eliminate. Right? If it was +14 and +14, if I add, I get 28h. I want to eliminate it, so I need them to be opposite signs.
Couldn't you have just subtracted them?
Yes. So again, the reason why I don't use subtraction is, again, I've just seen so many people make careless mistakes. When people add, they do not make as many careless mistakes as when they subtract. Yeah, and that's just from experience. But again, if you're good with subtracting and you don't make careless mistakes like that, feel free to subtract. All right, so adding those, I eliminate the h's. I get 1t, and I get 250. Now watch this, guys. If you go back and you read the directions, it asks, how many t-shirts are sold? We solved for t, so 250 t-shirts. Do I need to plug it in to find h? No, because they don't ask us how many hats. They ask us how many t-shirts. So I'm done.